Are you preparing for the State of Texas Assessment of Academic Readiness exams? In this video, we are going to teach you questions on functions as a grade 8 mathematics student that can truly help you excel in your exams. The STAR grade 8 mathematics reference material have given out questions on all materials on linear equations, circumference area, surface area, volume, and additional information that can help students answer a lot of questions like this on functions. So in this video, we're going to look at 7 to 8 or 9 questions on functions that you might most likely see in your exams. And these questions are the kind of questions that you will see once you start taking your exams this month and next month. Now, let's look at some of these questions and then see how we can provide solutions to these questions. We're going to start by taking the first question. And the first question is this. It says the coordinates of the vertices of a rectangle are A 5, 3, B 5, -9, C point -1, -9, and D -1, 3. Now the question says which measurement is closest to the distance between point B and point D in units. Now, how do you answer this question? This question is a question that is either on rectangle or on function. But we can use some similar formulas in function and in linear function and distances in order to solve this question. Now, the question says we should find the closest to the distance between point B and D. Now, how do we solve this question? If we want to look for the closest to the distance between point B and point D, we might decide to take the distance this way to this way, which is a bit longer, or we take this way to this way, which is a bit longer. Now, how about if we decide to take it diagonally? We take this way to this way. That way, we'll be looking at just this coordinate D and the coordinate B. I think that will be fine. Now, if we look at that, we're going to have two coordinates, coordinate B to deal with, and coordinate B is 5, -9, and then we'll have coordinate D, which is -1, 3. Now, let's look at how we can work with these two coordinates. Now, recall that under distance or under coordinate geometry, we have the formula for distance D to be equal to the square root of the side x2 minus x1 all squared, and this is plus y2 minus y1 all squared. So we're going to work with this and then we'll use this to find out the solution to that question. Now, in order to solve this, we're going to find the value of D. Now, the value of D will be equal to the total square root of x1 is what? We're going to have this to be x1. This is y1, while this is x2. This become y2. So if we look at that, we're going to have that expression to become x2 minus x1, and that is -1 minus -5, right, all squared, and this will be plus y2 is going to give us 3 minus what do we have there? That's going to give us 3 minus, and y1 is going to give us minus negative 9, right? All squared. So the value of our d will be equal to negative minus 5. That is going to give us the total square root of minus 6 squared plus 3 minus is going to give us what? Plus 9 plus 3 is going to give us 12. So we're going to have 12 squared. So the value of our d will be equal to the total square root of negative square is positive, 6 square is going to give us 36 plus 12 square is going to give us 144. So if we square 144, we're going to have the value of our d to be equal to the total square root of 36 plus 146. 6 plus 4 is going to give us 10, write 0, carry 1. 3 plus 4 is 7, plus 1 is 8, and that will give us 180. So if you point your calculator and find the value of square root of 180, square root of 180 is going to give us 13.4. So that is going to give us 13.4 units. And the right option for that question is option D, which is what? Option B, which is 13.4. So you see, that is the solution to that question 17. Now let's look at question number 11. Question number 11 from our 2023 STAR test exam says the graph of a linear function is shown on the coordinate grid. Here we have the value of the coordinates. Here we have the y coordinate, we have the y, and here we have the x, right? Good. And this is a point on the coordinate 4,8. Y, this is a point on the coordinate minus 5, minus 7, and this is a linear function. That's a graph. The question now says, what is the y-intercept of the graph of this function? So the question says we should find the y-intercept of the graph of this function. Now let's go back to if we go back to the question given to us, the material given to us, we're going to find out that the y-intercept, the slope-intercept form is y minus mx plus b. So we're going to use that formula to find the y-intercept. To find the y-intercept, we're given the value of y to be equal to mx plus b, where b is the y-intercept, right? From that linear function expression. Now we're given two intercepts. We're given 2 points, point 4,8 and point minus 5, minus 7. So if we can find the slope, and then we can find the intercept. If we can find the slope and then we have 2 points, or we use one of these points, we can find the intercept. So the question is, let's find the slope. Remember that the expression for the slope, we have the expression for the slope also given to us in the material, which makes it easier for you. The slope of the line is y2 minus y1 divided by x2 minus x1, and that is the expression over here. So if we have that, we have 2 points on the graph. And what are the 2 points? We have the first point, which is 4,8, and we have the second point, which is negative 5, negative 7. So over here we have we are going to have x2, and this is y2, while we have x1 and then we'll have y1, right? So for apply that, our midpoint m will be equal to y2 minus y1 divided by x2 minus x1. So our slope is equal to y2 is equal to -7 minus y1 is equal to 8. If we divide this, x2 is equal to -5 minus x1 is what? Is 4. Now if we simplify that, we have -7 minus 8. That is going to give us a -15, right? We have -15 divided by, this is going to give us a -9. So what do we have here? Negative cancel out negative, and then we'll have our slope. We'll have 3 here will give us 3. 3 over here will give us 5. So we're going to have the value of our m, or the slope, to be equal to 5 divided by 3. So if we have our slope to be equal to 5 divided by 3, that means we can easily find the value of our intercept. Now using any of those points, remember our y, remember the value of our y is equal to slope multiplied by x plus the intercept, right? And we are looking for the intercept. Now let's use any of the point given to us. We are going to first of all use the point slope, which is this, and the point 4,8. Now if we do that, the value of our y will be equal to y will be equal to 8, while the value of our x will be equal to 4. So if we put that into this equation, we're going to have 8 to be equal to 5 divided by 3 multiplied by 4 plus b, which is the intercept. If we simplify that, we're going to have this to become 8 to be equal to, this is going to give us 20 divided by 3 plus b. Now we want to look for the intercept, right? We want to look for the intercept. That means 20 divided by 3, we have to subtract both sides by 20 divided by 3, and if we do that, we're going to have that expression to give us 8 minus 20 divided by 3, and this will be the value of b. Now if we simplify this, you're going to have that expression. Once we use this, we're going to have this expression to give us 3 using the LCM. 3 divided by 1 is going to give us 3. 3 times 8 is going to give us 24, right? We will have 24 minus 3 divided by 3 is 1. 1 times 20 is going to give us 20, right? And this is going to give us 24 minus 20 is 4 divided by 3, which is automatically the value of our intercept b. Do we have it in the option? Of course, yes, we do have it in the option, and that is D. Right? So we can still decide to use the second coordinate point. And if you use the second coordinate point, you're going to have that expression to give us y m is 5 divided by 3. We'll have y to be equal to -7, and we'll have x to be equal to -5. Now I want you to apply it into this expression. You have -7, right, equal to -5 multiplied by 5 divided by 3, right? and this will be plus b. So this is going to give you negative 7 equal to negative 25 divided by 3 plus b. Now if you simplify this by taking this to the other side, you're going to find out that this is going to give us negative 7 plus 25 divided by 3, and that will be the value of b. Now if you simplify this by taking the LCM, you're going to find out that this is still going to give you 3. 3 divided by 1 is what? Is 3. 3 times 7 is going to give us negative 21, plus 3 divided by 3 is going to give us 1. 1 times 25 is going to give us 25. So when you simplify this, minus 21 plus 25 is still going to give us what? 4 divided by 3. So you see, whichever point you use, as long as you have you use the same slope, 5 divided by 3, you're going to have the value option D to be the answer to that question. So whatever solution you prefer, or whichever method you decide to use, you're going to have that solution, and that is why it is the slope. All you need is just to find the intercept. You need just the slope and the one of the coordinate point. That's all. So let's look at the next question. Which graph does not represent y as a function of x? Now, in order to answer this question, I'm going to give you the definition of a function, and then I'll give you 2 tips that can help you answer a question like this. 1, you've come to learn that a function is a relation where each input, which is the x value, has exactly an output, which is the y value. Now, in function, for every input, you must have an exact value of what? Output. And there is no way you can have one input without having a reciprocal output. Now, take these 2 tips if you want to answer this kind of question. To answer this kind of question, in order to identify if a graph is a graph of a function, you need to use the vertical line test or the mapping of x to y. Now, what is the vertical line test? In the vertical line test, we know that no vertical line must intercept the graph more than once. What does that mean? That means a single x value must not give more than one y value. Now, for every x value on the Cartesian of the graph must give just one y value. So if a vertical line touches the graph in 2 or more points, then it does not represent y as a function of x. If that is taken, now let's use that to analyze the graph. Now, the other one, mapping, which is not found here, says for every x value, there should be an exact y value. Now, let's use this principle in solving this question. From this question now, let's analyze or check the first graph. Now, for the first graph, for every coordinated point, there is a value of x and a reciprocal value of y. Now, for this coordinated point, we have the value of x, which is minus 2, and a coordinated value of y, which is minus 4. For this, we have a coordinated value of x, which is 4, and a coordinated value of y, which is what? 1. For this, we have a coordinated value of x, which is 2, and a coordinated value of y, which is 0. For this, we have a coordinated value of x, which is 0, and a coordinated value of y, which is negative 2. For this, we have a coordinated value of x, which is minus 4, and a coordinated value of y, which is negative what? 1. So you see, for each point, there is a corresponding value of y. For each input, we have a corresponding value of y as an output. Now let's check the other graph. For this point, there is a corresponding value of x, which is 2, and a corresponding value of y, which is 2. For this point, there is a corresponding value of x, which is 0, and a corresponding value of y, which is negative 1. So that represents a function. Now, for this other graph, we can look at this other graph. At every coordinated point, there is a value for x and also a value for what? And also a value for y, right? There is a value of x and also a value for y. Now let's look at this point. Remember, the principle says if a vertical line touches the graph in 2 or more points, then it does not represent y as a function of x. Now, does this line cut the graph in more than 2 places? Yes. This line cuts the graph here. It also cuts the graph here, and is about to cut the graph here. So it cut the graph in more than 2 places. So what does that tell us? That this graph does not represent y as a function of x. So the graph that does not represent y as a function of x is the graph with the option G, and that is the solution, the answer to this question. Now let's look at the next question. In the next question, we are given these sets of ordered pairs. The question says, which set of ordered pairs represent y as a function of x? Which set of ordered pairs represent y as a function of x? Now, how do we solve this question? Now, to determine the set of order that represent y as a function of x, we need to check whether each x value is paired with exactly one y value. Remember the principle, each x value must be paired with one y value. Each input must give us a corresponding output. And 2, mapping. The mapping of x to y says that for every x value, there should be an exactly one y value. Now let's test. For f, we have the value of x 4, 2, 1, 1. And remember, in expression like this, the first value is the x and the y is the second value, which is the output. So the x value 1 in the first expression appears 2 times, right? Appears here and here. Now, do they have different outputs? Yes, they have different outputs. Y is root 3 and the other one, y is root 10. That is not a function. Do you know why? Because we will have an expression y equal to x squared. Here, x is a function of y. If I input the value of x here to be 1, I'll definitely have a value for y, right? I cannot put the same function, the same value of x here, 1, and still get the same output. It must give me the same output. It will not give me a different output. So if one value of x gives me 2 different values, that means that value of y is not a function of x. So this expression, for we to have a single value of x appearing 2 times with 2 different outputs, that tells us that this paired order does not represent a function of x. Now, in the next question, we have 2 values of x, negative 15 and negative 15, minus 7 and minus 7. Now, do you notice something, that they all have different values for different values of y? Now, if I input in this expression, for example, if I input the value of -7 as an x, definitely I'll have a value for y, right? What if I still input -7 here? Will I still have the same value of y? Yes, it will not give me different value of y. So that means this does not work represent. So -7, -7 gave me different output. So that means this expression is not a what? Is not a function. Now let's look at the h option. In the next h option, we have the value of 11.1 giving me 7, 5.1 giving me 4, 12.1 giving me 5, and 6.1 giving me 7. Now if you look at that expression, you find out that every value of x is unique and they have different output. So that tells us that if I put the value of x here, it will give me a different output for y. If I put a different value of y, x, it will give me a different output for y. That shows that y here is serves as a function of x, and that way this is the right option. Now, if we analyze the option D, you find out that we have the square root of 1, which is square root of 1, which is 1, because square root of 1 square will give us 1. So if you put in x square root of 1, you should have an output -3. And now I'm putting it square root of 1 again, having a different output. No, that is not a function. It should give me the same output. So that shows that this is also not a function and this is not a function. The right function we'll have is this. So remember the rule that every x value or every input that is value of x must give me an exact one y value output, and that is the principle. So let's look at the next question. The next question says a linear graph is represented on the coordinate graph. What is the y-intercept of the graph? This question requires that we find the y-intercept of the graph. Now remember, I told you earlier on that to find the y-intercept of a graph, we are given the formula of the linear function to be equal to y equal to mx plus b. yb is the y-intercept, right? Good. So for we to find the y-intercept of the graph, all we need is the slope m. We need to find the slope, and then we need one of the coordinates. Those are the two things we need. This is 1 and this is 2. So if we get the slope, we can use any of these coordinates to find the y-intercept of the function. Now let's look at the slope. M is equal to y2 minus y1 divided by x2 minus x1, and that is the formula for finding the slope. Now remember, from this expression we'll have 0, 5, and then we'll have 8, -2, where this is x1, right? This is y1, this is x2, and this is y2. So if we simplify that, we're going to have slope to be equal to y2 is -2 minus y1 is 5, right? Divided by x2 is 8 minus x1 is 0. So this is going to give us negative 7 divided by 8, right? And that is the midpoint. That is the slope. Now, for us to get the slope, remember, for us to get the intercept, we need the slope, and we're cutting the slope. We have our m to be equal to negative 7 divided by 8, and we need a midpoint, and let's take that to be 0, 5. We need a coordinate. So given our y, this is our x and this is our y. So if we use the expression y equal to mx, we can find the intercept, which is b. From here, y is 5, right? And from here, the slope is negative 7 divided by 8 multiplied by x 0 plus b. And remember, we are looking for the value of b. So minus 7 divided by 8 times 0 is going to give us 0. So we're going to have 5 to be equal to b, right? So the value of the intercept 5 is equal to what? The b is equal to 5, which is option F. That is it. So what if I decide to use the other? What if I decide to use the other coordinates? Then remember that if I want to use the other coordinates, then I'm going to have my y to be equal to mx plus b, and I'll have the coordinate to be 8, negative 2. From there, my y is going to be a negative 2 equal to my m is negative 7 divided by 8. My x is going to be 8, and this will be plus b, right? And over here you see that 8 will cancel out 8, and then I'm going to have that expression to now give me negative 2 equal to negative 7 plus b. Now if I add 7 to both sides, I'll have negative 7. If I add 7 to both sides, I'll have negative 2 plus 7 equal to b, right? So this is going to give me minus 2 plus 7 is going to give me 5, and this will be equal to b. So you see, if you use any of those coordinates, you are going to have the same value and the same result. So the intercept of the graph of this function is f, and that is that. Now let's look at the next question. In the next question, we are asked to represent this expression to which representation shows y as a function of x. Now remember the helpful tips I gave to you. Remember the vertical line test and the mapping of x to y. We're going to use that rule here. Remember, the vertical line test says that if a vertical line touches the graph in 2 or more points, then it does not represent y as a function of x. Now, the mapping of x to y rule says that for every x value, there should be an exact y, one y axis. For every x value, there should be an exactly one y value. Now let's use those two rules to analyze each of these graphs. For the graph of f, this vertical line crosses the graph at several points, right? These points, this point, and what? This point. Hence, this does not represent the function. Now, let's look at the next graph. From the next graph, you can see that for every value of x, which is 2, we have two values for y and this, right? And for here we have two values of y, this and this, for the value of x. So that shows that this is not a function, because one value of x should give us an exactly one value for y. So this does not represent a function. Now let's go to the mapping. If we go to the mapping, from this mapping on J, you find out that 16 maps 19. Fine. That is x value mapping exactly one y value. 18 maps 21. 20 maps 23. For 22, what's happening to 22? 22 is mapping 25 and also mapping 27. That is wrong. Mapping of x to y states, the rule states that for every x value, there should be an exactly one y value. So this is not a function. So let's look at the next. In the next, we find out that the value negative, the x value -1 is mapping 60, -4 is mapping 47, -17 is mapping 34, and -20 is mapping 21. Great. So mapping of x to y, for every x value we have a singular and exact y output. That makes this a what? This a function. So the graph that represents y as a function of x is the graph of what? H. And that is the solution to this question. Now let's analyze the last question, which is question 19. Question 19 says, which set of ordered pairs represent y as a function of x? Now we're going to apply that same principle. Remember, in this principle, for us to determine which set represents y as a function of x, we need to check whether each x value is paired with exactly one y value. If each x value is paired with more than one y value, that is not a function. Good. But if each x value is paired with just one y value, that is a function. Now let's analyze, let's check the first option. From the first option, remember the formula or the definition of a function, that is a relation where each input x value has exactly one output. So if any x value is repeated with different y value, this relation or that relation is not a function. Now let's check. We have 0x giving us 0.5, 2 giving us 1.5, -5.5 giving us 5, and -5.5 giving us -6. Now from this relation, you'll find out that x value -5.5 is repeated with different y value 5 and 6. That tells us that this is not a function. Now let's look at the next option. We have 5x value giving us -7, 3x value giving us -7, 9 minus 9.2x value giving us -7, and 9.2 value of x giving us -7. Now we see that all the values of y are the same with different values of x. That is unique and that is a function. Why? Because we will have a value of this as a function, x plus 2. For every value of x we insert, we must have a different value of what? Y. Right? Good. Now if we have insert a different value of x here, we should have a different value of y. Now if we are dealing with different function, y equal to x squared, then if we put the same value of x here, 5 here, you expect a different value of y, right? Because this plus this will give us this. Now, if we still put that same value of 5 here, we can still expect the same value of y. It's possible. It all depends on what the input is. So x here is very unique. It all depends what the definition of the function is. So x here is very unique. With that, we can see that each x value is unique. For different type of function, we have the same what? The same output. So that tells us that this is a what? This is a function. Now, if we analyze the third question, you'll find out that we have 9.3 giving us -1. We have x value, 7.3 x value is repeated, while the y value is what? They're all -2 and 2, which is different. 9.3 is repeated and the output is different. So that tells us that this is not a function. Now in this we have different, the same value of s giving us different output, right? That is not a function, because the rule is if any x value is repeated, then it must give us a different value of y, or each value of x should give us a different value of y. So from that, we can see that the only option that represents the order that represents y as a function of x is option B. That is the rule. And we see that the correct option is option B. And this is the solution to these questions given to us under what? Under function. So you see, having analyzed all these questions, I think you can be able to look at questions under function and be able to answer these questions comfortably without any issue. If you have any question, you turn on to our channel, as we'll be dropping some other questions on the Pythagoras theorem, which will help you answer questions on your STAR grade 8 examination, mathematics examination, that comes up on the Pythagoras theorem. Don't forget to give this video a thumbs up, share it with friends and colleagues, and subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye for now.